Okay folks, we are back, and now that we have our primary controller, our primary control logic set up with a file in it, our secondary controller set up with a file in it, what we need to do is show you how to connect to a legacy controller. So the controllers of course are going to be used in compact logics as well on brand new applications or newer applications. Now what we're going to use is a SLC controller as something we call a legacy controller. So a legacy controller is something that was installed in the field previously but wouldn't necessarily be used in a brand new project. The important part here is these legacy controllers, there's thousands of them installed all over North America, worldwide, etc. So you need to know how to connect to both a controller that's used in new applications as well as a controller that was used in previous applications and is still installed regularly in the field. So what I want you to do is go into the Lab 2 folder on the Y drive under our SCADA course, copy over the Lab 2 template.rss file, paste it on your desktop, and remove the read-only properties. Once you've done that, go ahead and open up the template file, and we're going to do a save as. So I want you to save it as Lab 2 SCAD with your initials. Okay. So I've used this file before, so I'm simply going to overwrite it, but this will be new for you. Okay, so let's do the configuration that we require. So what we're going to do is take a trip down memory lane here and see how much you recall from early last semester and all the way back into Integrated Auto 1. Probably seems like a lifetime ago for you. So if we go into channel 1 channel configuration, you recall we need to set up our node address. So you guys, based on the green sign that you're sitting at inside the programming lab, need to know, of course, what node address needs to be applied to your SLC controller. So you look that up with the table that's provided to you. Go ahead and change it here. Once you're happy with it, simply say OK to close that up. And the other thing I want to show you is if you go into the I/O configuration, okay, well, I've already set up these modules for you, so we don't need to spend time going back on setting this entire rack up. So this default file will take, or this template file will take care of that for you. But what you will need to do is jump into slot number 8 here. If you recall, we have a remote I/O scanner loaded there. We're going to go into our edit group data, okay, and simply select a full rack for logical rack 0. Alright, to ensure that the remote I/O scanner has something configured so it doesn't fault on us. And we're going to say OK. Simply click OK from here, and we can close up our I/O configuration and save the file. Now, something that's vitally important here, if you recall back in Integrated Auto 1, you would have been connecting two jumpers at the back of the lab. One would allow you to download, that's the Data Highway Plus connection. The other one, the Remote I/O connection, would allow you to control or connect to the FlexIO modules that are sitting out on each work cell. Well, we don't want to control them with this particular processor. In fact, this processor, as a legacy controller, we're going to utilize as the part of the process known as the boiling part. Okay, so that's going to sit alone with some predefined addresses in it and some logic down the road, but we're not going to be physically controlling the work cell from this particular controller. So we need to make sure that remote I/O connection is not made at the back of the lab. Alright, so with our controller configured, we can go ahead and add a rung of logic, very similar to what we did in the RSLogix 5000 files. So with an XIC and an OTE set up, I'm going to highlight, throw an address in here of B30/0. What I want you to use for the description is HMI boiling push button, again because this particular processor is going to be in charge of the boiling part of the process. I'm going to copy that description, put the address of B30:1 on the OTE, paste in the description, alter it, so now we're dealing with the boiling light. Okay, and we'll verify that rung and save up the file. So the next step is to simply download this logic to the SLC controller. So if I go into my comms and system comms, okay, I'm going to minimize these drivers to take you from the top. So if you recall, we have to use a gateway, and in order to get to that SLC, so we're going to go over Ethernet at the back of the computer connect up to the gateway at the back of the lab, and then ultimately convert over to Data Highway Plus based on those cards that are loaded into the gateway rack at the back of the lab. So we're going to expand our Ethernet driver, then we're going to expand on our gateway IP address, and you notice here my gateway IP address is .201. If you recall, you guys in the lab will in fact be using .200 to go find your SLC. So expand your gateway address, expand the backplane, and we're going to open up all the cards, of course, that are sitting in that chassis. So I'm just going to minimize this again. So make your way down to the card loaded into slot number 10, which is that Data Highway Plus Remote I/O combo communication card, and we'll simply expand, and then it's up to you depending on whether your SLC is on channel A or channel B based on the table you're provided. In this case, mine's under channel A. Of course, I'll highlight up the processor and go ahead and download to it. So we'll follow through the prompts, and again, either bringing back nightmares or you'll find this process pretty straightforward. And we'll go ahead and put our program into, or our processor into run mode here. Okay, with our file downloaded, we're back in run mode, all connected here on our SLC. We are ready to go back into the lab and look at what is next. Eventually what we're going to do is set up FTalk View to be able to monitor and control this particular application, as well as the other two that you loaded into the control objects. I will be back at you soon.